You are indeed up, worshipful brother.
All right, hold on here. And make it big. There we go. So, yes, I was worshipful brother, or the worshipful master in Rochester Lodge number 21 in 2012, which seems like a long time. But it really was a tremendous opportunity. And now I'm the lodge education officer there. And so we do our best to bring different presentations from, in fact, we've had people presenting from all over the country due to this whole COVID-19 thing going on. And so this is bringing back one of the presentations that I created a little while ago. And so now we're bringing it up to the Grand Lodge. So with this, please enjoy, and then we'll have questions and comments and discussions when we get done. So here's the agenda. We're going to talk about these three types of squares that are used by operative masons: the square gauge, the tri, and the gallows square. And definition for you'll see this pattern going on. I'll define the square or the gauge in terms of its operative features, and then we'll get into the speculative kind of version of that. So the square gauge for the operative masons, it's a gauge to allow you to be able to measure the enclosed square, so kind of the inside dimension of an ashlar, which of course is a cubic structure, or the cross section. So picture at a time when people really didn't know how to use the markings or rulers on a gauge. On a square would allow you to have and in this time the squares were sometimes rectangular, or it could be a square gauge, but allowed people to be able to understand and say, okay, if I've got this, I can hold it up against this ashlar, and to see that, oh, here's a piece of the ashlar that needs to be chipped away, and so they can chip away then at that ashlar in order to make it a perfect ashlar. So that's called the square gauge. In a speculative sense, when you're admitted to be into the fellowcraft, you're told as a candidate that you're being obligated within the square. You're now being bound to act upon this as a square to all mankind. This really derives from the practice of requiring, in ancient times, a candidate to kneel on both knees on a bare ashlar stone placed with that square gauge. And the reason for this change is not recorded, but the present method to support the candidate's elbow with an angle with a small Pythagorean square, which is a square that has maybe 4 units on one side and 3 units on the other side for a Pythagorean square, was substituted for this operative practice. And at about the time that there was a reconciliation between the ancients and the moderns. And by the way, I went over it too quick. Back to beginning here. This presentation was pulled largely from the works of a Right Worshipful Brother Donald H.B. Falconer down at the Grand Lodge of New South Wales in Australia, called The Working Tools of the Craft. And in the presentation, there's a link to a PDF that's got this information in there. So I didn't invent any of these things. A lot of these things are his assessment and his studies. So back to the presentation. Here, so that's the uses then of this speculative square gauge. The next one we'll take a look at is the tri-square, and you can see an image here. In fact, in my kit, for all the different tools that I inherited from my father, who was also a mason, with all that kit that's available, I've got some examples of these square gauges and other kinds of squares that I use around the house just for doing some simple woodwork. I'm not by any means any kind of craftsman, but I have some of these. So here's the tri-square. And this is really a square that's got 2 arms of equal length. It includes, of course, that angle of 90 degrees. And it's not calibrated, it's not measured. It has no markings on it in terms of the lengths of the arms, because it's only really used to set up against that ashlar to measure the perfect faces of the ashlar, to make sure that they're meeting at that 90-degree angle. So that's the operative use of the tri-square. But we as free and accepted masons are taught to make use of it for the more noble and glorious purposes of, I'm just segueing here into, this is really this tri-square because the legs of both of the sides of the squares are of equal length, is really very much the traditional square and compass. If you take a look at the lower right of the presentation, down here on our, the Grand Lodge of Minnesota's icon here, you can see this is a tri-square as represented as part of the logo here. Second bullet there is because the tri-square is used to test these angles of this perfect ashlar, this 90-degree angle. It's kind of a universal emblem of morality and justice. And in fact, we find comments about that in the Bible, and where we're talking, where we try to make use of it in terms of expressing ourselves as living stones, wanting to be this imperfect ashlar to be a perfect ashlar. And you can see the two Bible verses there that this is quoted in. So it's the speculative version of the tri-square. Then the Gallows square. This is another one. In fact, this is a picture of my Gallows square, and there's another one that I have in my kit. And you can see the difference here. There's markings on the Gallows square, and two, the lengths of the edges are of different lengths. So the operative masons use the Gallows square to set out right angles, of course, but it's also to set out the column bases and wall recesses. So you can use the measurements and the markings to either say it's going to be 1 Gallows square units or 2 Gallows square units, and so you can actually use this as part of your measuring and laying out your walls, your recesses, your flooring, your ceiling, and any kind of different kinds of arches, as long as, of course, you're working with the right angles. So the Gallows square, from an operative point of view, has two arms of unequal length at that 90-degree angle, of course. And they're calibrated both on the inside and the outside with measurements, making so that you can then scribe on the stones, or for me, of course, it's just scribing on a piece of wood, and they've got nice, beautiful long edge on them that you can just mark with them. So it's a really useful tool, I found, for doing a lot of my very, again, simple kind of woodwork around the house. So they usually have the usual sizes in these operative lodges, where a small and a large ratio square, this 2 to 3, either being the 18-inch by 12-inch by 18-inch arms, or the 24 by 36-inch arms. So the second or the first and third bullets there. But also, too, there was a general purpose 3 to 4 ratio Pythagorean square, having a one side being 18 inches, the other side being 24 inches, and what would be the hypotenuse of that Pythagorean square? Somebody quick. A squared plus b squared equals c squared. I have to admit, I had to do the math myself, but it would be 30 inches along the diagonal for that Pythagorean square. From a speculative point of view, that Gallows square with that Pythagorean ratio was traditionally the emblem of the master, and that is still used as a master's emblem by most of the continental Freemasons over in Europe. But for some reason, according to this Right Worship Brothers study, that was not been recorded. Apparently, in the 1830s, it was changed to be something that looked more like the tri-square, so it was more symmetric and even lengths on each of the sides. And the thought is that it was perhaps is better suited for early speculative rituals' passion for symmetry. And in the United States, the tri-square has been marked in. We see a lot of times that the tri-square, the one that has the same length edges on it, usually has some kind of markings on it for inches and fractions, so implying that it might be used for measurements as well. And then, of course, the master's jewel is a symbolic reminder, again, in the speculative masons here, that a lodge should be justly and properly ruled by the square conduct and impartial decisions of the master. Then we have this thing called the oblong square. And so what really is that? And the research by, this is from a brother, C.C. Hunt, a deputy grand secretary down at Iowa, had researched this a little bit differently. His thought was that at one time, the word square meant it was right angled. And so the term square in this sense can refer to any four-sided figure having the 4 right angles. And basically, a square in the sense could be one that is like our square, where all 4 sides are equal, or what we would call a rectangle today, where the two parallel sides are longer than the two. So the first of these, where all four sides are equal of the oblong square, that would be called a perfect square. And then the second class, kind of a subclass of that, would be the oblong square. So you can picture your feet, as you're coming into the lodge, right? And as you're standing before the master and the altar for the first time there. And in that situation, right, we talk about the oblong square, and of course we talk about the perfect square. And so it's really should be no surprise that as a master mason, right, as we reach for and try to get to that extra level of perfection, of course we never reach it. Right? We're always imperfect ashlars trying to work towards that perfection, but that it would be that the master mason would be something that would be looking forward to be the perfect square rather than the oblong square for the previous first 2 degrees. So kind of in conclusion here, that the symbolism that is found in the various third degrees is really a recognition that we're always trying to, as Masons, strive towards that perfection. Again, we'll never get there, but we always strive towards that perfection. That's the end of the presentation. So at this time would be questions or comments or thoughts.
Excellent, thank you.
Yeah, it was very nice. Thank you very much.
I said a lot of the study, I've got you can see the links are in the presentation. And I've posted these to the Lodge Education Officers Facebook page. So this presentation plus all my other presentations are there. So you can open up the presentation, and inside of there will be the links that you can follow to get additional information and a deeper dive into kind of this view of the speculative side of the squares. I did the kind of mining in the internet and looking for examples of the operative squares, just to kind of give us a visual representation of what was discussed.
I appreciate that. As a speculative carpenter coming into the fraternity, I was. It took me a little while to find a square that matches up, and I like to hit the swappers meets and the antique locations, and it's very interesting because you seem to not find very many squares. There's many other tools, but I actually have an old compass. The old compass actually is from my grandpa, but yeah, it's pretty cool. I love talking about the references to some actual working tools, for sure.
Brian?
Yes.
Yeah.
Yes, go ahead.
John Freeberg from Anoka Lodge. I have a question. When did the tools start to have calibration marks on them?
I don't know that as I was looking through this and all that, but this is going to be just speculation from a speculative Mason. And that is, the markings would not have been very useful for individuals who couldn't read or write. And so those markings, if it was 9 or 10, if you don't have a basis in mathematics, they would not have been too useful. So I would think that it would have been, as maybe our education got a little bit better, in the late Middle Ages, or the early, say 1700s or 1800s, when those markings would have appeared, and we had standardized units in terms of inches, which is of course a crazy standardized units, but even then centimeters after that. So this is just speculation on my part, but I don't know the answer to that. Good question.
Okay, thank you.
Anything else? Otherwise, I'll tell you another story. So this, I don't know if you know about the Great
Plumb bob was
Lakes.
used as a square at one time.
What was that, please?
You believe the plumb bob was used as a square?
Sure, right? It obviously tells us what is, the perpendicular. And if you got something that's perpendicular, then well, okay, how? Was that a question, or you were making the statement that it was being used as a square?
I believe it was used as a square. I've heard a couple carpenters say it was used as a square at one point.
I was kind of trying to theorize the how. Might you know, or might anybody else know?
I'm not sure. It was an older gentleman that told me about it, and unfortunately, he has passed.
You know, I can only theorize that if I wanted to be able to identify a point directly over a lineal state, then I could see utilizing that to create that square reference.
Yeah, you'd have to marry that with a level, right?
Yep. So
Yeah, because otherwise you wouldn't know that the angle was 90 degrees. Well, if you had two plumb bobs, and then you could measure the diagonal distance between the corners, because if you've got a rectangular shape and you measure the distance between the corners diagonally, if the angles are all four angles are 90 degrees, then that measurement will be exactly the same. So it'll be 50 feet diagonal, 50 feet diagonal, then you know your rectangle or square is square. So yeah, it could be used as long as you had a level and a plumb bob, and then something to measure distance, which is easy, of course. You just need a
Yeah, it's just something that's always stuck with me. It was interesting.
Yeah.
I was a machinist in school, so.
I was a programmer.
Dr. O'Brien,
Yes.
could you speak to how squares were being made?
Being made?
Yeah. I
No,
mean, in olden days, obviously, having a square was a precious possession, but in the operations, these things got bent and deflected and the like, and there were various techniques that are documented as to how squares were made on the fly, and maybe you could elaborate on that.
No, I cannot. No, I cannot. Do you have some additional? Do you remember, or some of the lessons?
Yeah, there's some techniques where you use the rope, right? So you have a 12 knotted a rope with 12 knots in there, and you basically recreate. You didn't necessarily have to use or have to know any math or the like. You just we're told that count to 4, count to 3, bend the rope over, and basically stretch the notch, and that guarantees always a square. The other method was take 2 points and create 2 arcs, so basically 2 intersecting arcs, and then the line. So it's kind of I looked into it quite some time ago as to how squares were produced. I mean, I picture this medieval kind of a work where there was a lot of turmoil going on, and squares got damaged and the like. Yet, if you look at these cathedrals, they are pretty straight up for hundreds and hundreds of feet in the air. So,
yeah. One of the things I did, and I wish my brother Phelps would confirm this too, is in the Rochester Lodge number 21, I brought with me a rope it was 3 feet long with knots at the 1 foot mark. So there was 2 knots in it, but the total length of the rope was 3 feet. And then I had another rope with 4 feet, and I had another rope with 5 feet. And of course, this is Pythagorean's theorem: 3 squared plus 4 squared equals 5 squared. And I gave those to 3 different brothers, and I said, "Form for me, please, a perfect square." And by laying this out with each other, right, the 3 feet, the 4 feet, and then making sure then that the 5 feet goes from corner to corner, then that there's a perfect square at the hypotenuse of that. And so in like manner, you can imagine that the ancients, before they had the ability to do mathematics, they were given by some master a stick that was 3 units long, another stick that was 4 units long, another stick that was 5 units long, and with that they could manufacture a perfect square. And so it really is amazing what we humans have done over the years to be able to calculate and make these kinds of things, even without maybe understanding Pythagorean's theorem or the basics of the mathematics, just through trial and error and having a master, right, teach you, here's my trick for doing these different things.
yeah, the earliest records of how to make a square and how to stake off a square dates back in ancient Egypt, where upon the flooding of the Nile and the recess of the Nile, the fertile land needed to be restaked, because every time when the Nile floods, all the parcels are basically eliminated, right?
Mhm.
So when the Nile then recesses, then everything had to be restaked. And the guys who were doing that had some phenomenal techniques as to how you are kind of not only create square, but also partition a plot and the like. It's fascinating stuff, and dates back way, way beyond what we kind of casually assume.
Right. I mean, we all learned trigonometry in school, and here they were using let's say, features of trigonometry that eventually made it to Greece and were then, encapsulated in some of the lessons from Euclid and Pythagorean, kind of pulled together. All these, it's just a chain of learning, a chain of knowledge, and that is one of the wonderful things about Freemasonry, right? Is we try to continue this chain of education, and we have our masters teaching the younger members in our lodges. So it really is a tremendous, excellent. We are kind of at the same level that we humans have gone through over the years of trying to figure out something and making it work, and then going, Eureka, this is working. Now let me share this with the next generation.
And to add with a little bit of what Hans was sharing there, when I was one of the first Leos I put together for Nelson Lodge was on the apron. It was something that was a little fascinating with me. And one of the pieces of research I had come across had talked about that there's a lot of lodge aprons, or the operative mason was actually a square apron and could be used from that. They could find their right angles, they could find their triangles. They could generate steps and do a lot of layout just by literally using, it as a form of measurement. I thought that was pretty amazing.
Yeah, it'd be kind of cool to see an apron. We have so many aprons with bling on them and ruffles and all sorts of things. It'd be kind of nice to have an apron that just lays it out, right? Here's 10 centimeters and 20 centimeters, and you can actually use it to build a house if you needed to.
Yeah.
And it will hold on to your tools. Well, the other story is I was using another one of our working tools as an operative mason this summer. As you may or may not know, the Great Lakes are at historic high levels, and my family's cottage on Lake Michigan is being threatened by this high water. And so we call it a seawall, and it's a stone wall with masonry that my
Mike, can you speak into the microphone?
Sure.
You're cutting in and out.
That my father built back in the 1950s and 1960s, and still standing, except for now this high water is lapping at its the foot, and it eroded some of the wall away. So my older brother and I were stonemasons this summer for a day, and we got to put in stones and mortar, and I got to use my trowel for that, and so it kind of was it's a fun thing to do, is sometimes not just being a speculative mason, but actually working with the mortar, the stones, and actually being a real mason. And I'm happy to report that the wall is still standing. And as my brother and I have told my family, the wall is good for another 50 years, guaranteed for another 50 years, or until the next storm.
Until some of that big ice sheet comes across Superior. Huh?
Yeah, well, it's on Lake Michigan, but that's one of the things that we do have problems with is the ice sheets pushing in, and that was one of the main reasons for this wall, was to keep the ice from getting into the at the foundation of our cottage. Luckily, we've never had that problem because the wall has been standing. But yeah, it took a day, but it's a labor of love. Kind of working and shoring up what needs to be shored up.
Amen to that. Anytime we can put those working tools to practice.
That's exactly, yeah.
Hey, Brian, if somebody is interested in taking the oblong square a little bit further, there's an article written by, Rex Hutchins, called Thinking Outside the Box. It was published in the Philadelphia Society. It's a phenomenal thing where he mathematically and philosophically takes the oblong square and pretty much calculates everything that is known in modern geometry, from pi to phi to the Fibonacci sequence, etc. So it's called the Thinking Outside the Box: The Geometry of the Oblong Square by Rex Hutchins. It's definitely
Yes.
a read worthwhile.
Very good. Yeah, our Rochester Lodge number 21's Worship Brother Ken Olson's got a presentation where he goes through the kind of the medieval cathedral builders and the tools that they had at hand. And he shows us during the presentation of how he using a compass and a square to be able to calculate things like the Fibonacci sequence. Well, of course, and some other elemental things that are used by architects during the times of the building of the cathedrals in Europe, the Middle Ages. And so it's just a fantastic presentation.
Excellent. Great stuff. Well, thank you, brothers. We've reached that 7:30 hour. I've appreciated the opportunity to learn a little bit more about the square. And, as a Mason, that's one thing we should ever be present is learning and gaining more light. So I'd like to thank you. And is there anything? I'm going to go ahead and stop the recording. And if there's, we can just open discussion.